Welcome to the final part of our water pollution lecture series. This is part 3, non-chemical water pollution and water pollution legislation. Solid waste pollution. So if you guys remember in class, we've been watching a plastic ocean. And one of the topics that they discuss, obviously, is solid waste pollution in the ocean. Solid waste, such as what we call garbage, is made up of discarded materials that, by their definition, do not pose a direct toxic threat to human health. In the United States, solid waste is generally disposed of in sanitary landfills, but this isn't the case in many developing nations. We talked a little bit about that previously, that in places where sanitation and landfills aren't accessible, people throw their garbage into local waterways or in heaps outside their homes, and then that garbage ends up in the ocean. Solid waste, particularly plastic, is oftentimes deliberately dumped in the ocean or ends up there accidentally after washing down rivers to the sea, which contributes to oceanic pollution. Plastic pollution is unsightly, meaning it's ugly, but it can also harm aquatic life. Animals can ingest plastic and they can become sick and die, and we've seen examples of that. Plastic rings can become stuck around animals and discarded fishing nets as well, which is what you see in this picture over here with the seal, that right there, which is kind of heartbreaking. And they can either inhibit their growth, like you see with this turtle right here, or they can actually be strangled by it. And then finally, one of the things that we've been investigating in class is the small photodegraded plastic pieces. When they become pitted, when their surfaces become pitted with little craters, they become vectors for the transmission of aquatic diseases. These microbes they hitchhike on these little pieces of photodegraded plastic, and they are potentially very dangerous to particularly coral reefs because of the transmission of these diseases via these tiny plastic pieces. Solid waste pollution in water can also come from coal ash or coal slag that remains behind when coal is burned. This waste contains mercury, arsenic, and lead, and it's frequently dumped into landfills, or unlined ponds or abandoned mines where it can contaminate groundwater in any of those. The reason that can be dumped in these places is that the EPA deems fossil fuel waste like coal ash or coal slag as, quote, special waste, and it's exempted from federal regulations on hazardous waste. We have regulations that prohibit dumping of hazardous waste into landfills, but this special waste is exempt from those federal regulations, even though fossil fuel waste is demonstrably toxic. So just to let you know, this is a legislative loophole, and it was actually put into place by the Clinton administration. So there's a lot of political stuff going on when we talk about like the legislation and the categorization of waste like this. And it's not, one political party or the other. Both of them have interests in fossil fuels, and this exemption from the normal hazardous waste rules for fossil fuel waste is definitely problematic when it comes to groundwater pollution. In fact, there are actually very few regulations at the federal level or even state or local levels governing this disposal of coal ash and coal slag. So in 2008 in Kingston, Tennessee, actually right outside Kingston, Tennessee, there's a large coal-fired power plant there. And there was an accidental release of coal ash slurry that flowed into the Clinch and Emery rivers. And this was the result of heavy rains that flooded the ponds and collapsed a retaining wall at a coal-fired power plant. The release covered more than 300 acres of land. It actually destroyed and damaged several homes. There's pictures of it on the internet. And it killed tremendous numbers of fish as it entered the rivers. It was the largest coal ash release in U.S. history. Sediment pollution occurs when particles of sand, silt, or clay wash into bodies of water, which changes their natural turbidity and harms aquatic life. So, the transport of sediments by moving water is a natural phenomenon, but human activities can greatly increase the amount of sediment that enters waterways. Current estimates are that 30% of sediment pollution is natural and 70% is anthropogenic. Sediment pollution can be increased by the construction of buildings. When you clear land in order to construct a building, the land is bare and it's subject to wind and water erosion at that point. Sediment can also come from the erosion of plowed agricultural fields. The dirt is overturned, it's loose at that point. When the rains come, it washes sediment into nearby bodies of water. The removal of natural vegetation from stream and riverbanks due to agriculture. Sometimes when farmers have a stream or a river that runs through their property, they actually remove the natural vegetation there so that they can plow right up to the edge of the river. This has multiple implications, but when this happens, you end up, the vegetation keeps the banks in place, the roots of the vegetation, especially trees. And then when you remove them, those trees are gone, their roots no longer hold the bank in place, and you get sediment erosion. Also, the trampling of stream and riverbeds by domesticated livestock. Now, people don't often think of this, but when you're raising cows on land and they want to go into a body of water to get a drink or to cool off, cows are big animals with these kind of pointy hooves. And as they go down into the water, they actually trample the bank and they erode the bank as they go down. And over time, this can cause a significant amount of sediment erosion and sediment pollution into waterways. So what's the consequences of sediment pollution? Well, sediment pollution blocks the infiltration of sunlight, reducing photosynthesis by aquatic plants and algae, which reduces dissolved oxygen levels. So if you don't have sunlight penetrating the water column like you normally do, then these photosynthetic aquatic plants and algae can no longer do photosynthesis, and it reduces the dissolved oxygen level because those guys are putting out oxygen as a byproduct of photosynthesis. Sediment pollution also clogs the gills of fish, which can suffocate them. And then sediments eventually settle to the bottom of waterways, which clogs the gills of bottom-dwelling organisms like bivalves and other things that live on the bottom. And it eventually will suffocate them as well. They get buried and they suffocate. And then sediment pollution carries nutrients into waterways. If the sediment's washing off, particularly from agricultural areas, it's going to be carrying nitrogen and phosphorus with it, which increases the chance of cultural eutrophication in that waterway. Thermal pollution. Thermal pollution occurs when human activities cause a substantial change in the temperature of a body of water. We've talked about thermal pollution before when we talked about nuclear power plants. Thermal pollution most commonly occurs when an industry withdraws cold water from a source, such as a river or a lake, uses it to cool machinery or to absorb heat in an industrial process, and then discharges the warmer water back into the original source. Both coal-fired and nuclear power plants produce thermal pollution in this way. And other industries do too, to cool machinery and things like that, but the biggies are coal-fired and nuclear power plants. So what are the consequences of thermal pollution? Well, they include thermal shock, which generally leads to the death of an aquatic organism and possibly a loss of biodiversity. So when you put water that's either too cold or too hot in an organism's environment, and of course they're not adapted to that, they go into thermal shock and they can die. A lower dissolved oxygen level. Warmer water holds less dissolved oxygen than cooler water. So when you make the water warmer, the natural dissolved oxygen level is lower, and aquatic life that's not adapted to this cannot tolerate it. Also, warmer water can lead to an overgrowth of algae. And overgrowth of algae can lead to a number of different negative consequences. A lower dissolved oxygen level, because the algae increases the biochemical oxygen demand, which we talked about before. So the greater number of algae, the more oxygen in the water they take up. The more oxygen in the water they take up, the higher biochemical oxygen demand, and the less oxygen is available for other species. More algae also causes a reduction in photosynthesis for submerged vegetation. Because algae is normally present on the top of the water, the increased algal growth covers the surface, which blocks sunlight to the deeper plants. And then, of course, possible harm to aquatic life due to the increased release of algal toxins. Some species of algae actually release toxins from their body. And so when you have an algal overgrowth, you can actually have a fish kill event because the algae is putting out toxins into the water, which harm aquatic life. Noise pollution in the water, like sounds made by ship engines, like propellers, the pings made by submarines, and underwater sonar interfere with animal communication and navigation. There's evidence to support that cetacean breaching events, cetaceans meaning dolphins and whales, may be connected to noise pollution. So what are some sources of noise pollution and how do they affect aquatic species? If you take a peek here, we've got seismic and acoustic surveying ships. These are primarily used by the oil industry. They use an air gun where they shoot compressed air down towards the bottom of the ocean, and then they actually record what comes back with this hydrophone array. And these compressed air bubbles are actually very, very loud, and they can interfere with communication of whales and dolphins. This is a picture of a pipe-laying vessel, and again, pipe-laying vessels, they emit noise from them, and that can interfere with growth and reproduction of marine species. And then shipping containers, the propeller and the machinery of ships, particularly these very loud propellers, can also interfere with predator-prey interactions and communication all across long distances. The other thing, there's propellers often emit low frequency noise that really jams up the way that whales communicate across the ocean. And so when animals that communicate via sonar or pinging or singing underneath the ocean, when they communicate that way or they're navigating that way and there's a lot of noise in the area, they frequently become disoriented and confused, and they end up beaching themselves. So the Clean Water Act of 1972 is the first piece of legislation that you need to be aware of for this class. There was another earlier piece of legislation in the late 1940s, but you don't really need to know that. So the Clean Water Act of 1972 supports the protection and propagation of fish, shellfish, and wildlife and recreation in and on the water by maintaining and restoring the chemical, physical, and biological properties of surface waters. Whoops, I'm moving stuff around. And the surface water part is important here because when we were first looking at water quality in the United States in the 50s and 60s, it was surface water that we were primarily concerned about. At that time, there was a lot of industrial pollution in our surface waters. And so folks were primarily concerned with restoring the chemical properties of water. In more recent times, as water has become cleaner, we've been focusing on the biological, maintaining and cleaning up the biological properties of surface water. But in any case, all of that's covered. Anything surface water is covered by the Clean Water Act of 1972. So I realized when I made this here that as I'm talking, this should say the Safe Drinking Water, not Safe Water Drinking. The Safe Drinking Water Act of 1974. This sets the national standards for safe drinking water, hence the name Safe Drinking Water Act, and establishes maximum contaminant levels, which we call MCLs, for 77 elements and substances that can pollute surface and here's the key word, groundwater. A lot of our drinking water, it can come from either surface waters, but can also come from groundwater. So the Clean Water Act only covers surface water. The Safe Drinking Water Act covers contamination in groundwater. So that was important, obviously. All right, the third piece of legislation, and this one is not mentioned in your textbook, but you need to know it, is the Marine Protection, Research, and Sanctuaries Act of 1988. This is also known as the Ocean Dumping Act. This act prohibited transportation for the purpose of dumping and actual dumping of materials into U.S. and U.S. territorial seas. Now, here's the kicker. That means without a permit. You can still legally dump into the ocean, U.S. ocean and U.S. territorial seas, with a permit. You have to apply for a permit and you have to basically say, this is why I need to dump in the ocean. So this sounds like a great idea, but it is circumventable, and I'm going to unfortunately say fairly easily. If you can obtain a permit, you can still legally dump in the ocean. but it was designed to prevent that on a large scale. Water pollution legislation in developing countries lags behind that of developed countries. And we kind of have seen this. There's a lot of stuff that enters waterways in developing countries that we would not allow to enter waterways here in the US or even anywhere in Europe. But the water pollution legislation is improving as the hazards of polluted water become more clear and as these countries modernize and industrialize.